Hi, welcome to the episode 3 of the Getting to Know GIS series. We're looking at 5 basic concepts in GIS for this episode. These concepts are location, direction, distance, space, and navigation. For GIS, where the particular thing or phenomenon is happening is much important. The location inclined issues or location perspective of any phenomenon is important in GIS. So the first concept we want to talk about is location. Where is the phenomenon? So where are the issues you are talking about? So the where aspect of GIS is the location. Now, 3 types of locations can be put out in GIS perspectives. We have the nominal location, which most people refer to as toponymy, the absolute location, and relative location. An example given here is KNUST. So the nominal location can be KNUST. Somebody can just mention to you KNUST, and then if you know there, you know where the person is talking about. But then, for a more accurate location, there should be an absolute location which is calculated based on the Global Positioning Systems, GPS. So the same KNUST given as a nominal location, that's the toponymy, can still be attained by putting in the latitude and longitude GPS location of KNUST, 6.672 latitude, negative 1.586 longitude. These are coordinates of KNUST, which through this you can search for KNUST and you find it. The third location concept in GIS is the relative location. So apart from knowing the nominal location, that's KNUST, or identifying it using GPS latitudes and longitudes, where KNUST is can also be described in relative terms. So for instance, if somebody doesn't know KNUST can be described to the person using communities around it. So if you can see the picture below, you realize that KNUST is situated among some communities. You can see Kote, you can see Ayediasi, you can see Bwedi, and the other locations. So you can describe KNUST, where KNUST is, in relation to other known points around the same area. So these are the 3 basic aspects and the location as a concept in GIS. Another concept we are looking at is direction. For direction, 3 different aspects can also be put across. For instance, you can have ecocentric direction. So as a person, you can say that something is left to you, something is right to you, something is ahead you, something is at the back of you. These are directions pointing to a particular place using yourself or using the directional signs that you can use per yourself. Another thing has to do with using landmarks. So you can say that KNUST is closer to this particular landmark, is closer to the tech overhead, is closer to tech police station. So these are landmarks that you can use to give direction to somebody. But then the 2 may not be universally accepted. It cannot be traced by other people. So we can have a better direction point that can be traceable for others or universally accepted. These we use the north. So it can be the true north, it can be the magnetic north, or the grid that you have on a map. So if you are looking at true north, then you are looking at direction based on line through the North Pole. If you are using compasses, you can give directions based on the north, but then you are giving it through the magnetic North Pole. And then if you have a grid on your map, you can give directions based on the grid that you have on the map. If we talk about direction as a concept in GIS, you can have the self-egocentric directions, you can have directions based on landmarks, and then you can benchmark your directions based on the north. True north, magnetic north, and then the grid. Another concept is distance. So from one place to the other, what amount of time are you covering? What amount of distance are you covering? So we can have a nominal distance. So somebody can say that from Tech Junction to Edum, or from this place to this place, the distance is large, the distance is small, the distance is near, the distance is far. What makes it far, what makes it near is mostly depends on your patience. So what is far to you might not be far for me. What is near to you might not be nearer to me. So it depends on your experience as well, depends on your opinion about a particular place. If you have flying on a road before, you might realize that it's shorter than your first time of flying that particular road. So that is the nominal distance you can have in as a concept in GIS. But then what you think is near and far will be different looking at people's perspective. But then the actual distance can be calculated based on projections, and then it can be quantified in units. So using various mathematical formulas, you can arrive at 2 kilometers. So 2 kilometers can be calculated. 2 kilometers is 2 kilometers, 2 miles. So you attach a unit to it, you can quantify it, and then people can really relate to it scientifically. Another concept in GIS you want to talk about or consider is space. Now, everything that revolves around you happens in space. If you are talking about a phenomenon is happening in space. So this space can be described. It can be abstract as well. The space that you are working in can be described to somebody. The person who hasn't been there before, who haven't gotten there before, will see it as abstract with your description that you are given. Now, for GIS, we want to understand how and why things are distributed across the space. So you want to look at the disparity, the differences, topographical differences in phenomenon. You want to look at spatial differences in phenomenon. You want to look at temporal differences in phenomenon, and they are all happening in space. So if you want to look at topological space, then that will be your area of interest. So we want to consider, let's say, a phenomenon like erosion. So your area of interest, your topological space, will be a confined area that you want to understand how and why erosion is distributed, or erosion happened, or erosion have been happening in that particular defined area. Now you want to understand the various relations that are happening in the particular space. There are several things that goes on in the space. You have people interacting, you have topographical issues happening there, you have geographical issues happening there. So the space is made up of several things. So basically, are there relations among the things that you see in the space? And then if there are, what are the rules governing those kind of relations that exist? This is a concept in GIS, or what GIS is to establish. That is the space concept GIS. So if you can look at the map, Ghana map portrayed shown here, you'll see that we have a defined geographical space. So that will be our area of interest. We want to understand how the road network indicated in red are interlinked with the communities. Are there relationships between where a community is sited, where the roads are leading to, and if there are relationships, what are the rules governing the relationship that you have in the graphical space that is called Ghana? So space is very important if you are talking about. The concept you want to consider is navigation as a concept in GIS. Now you know your location, you know your direction, you know the distance you're supposed to cover. Now, how do you navigate to the place? 3 basic areas are being put up for this concept in GIS. You have the landmark knowledge, you have the route knowledge, and then you have the survey knowledge. Now, just imagine you get to a new place, and then you've relocated to a new place, and you have started learning about the place. What you learn first is a landmark. So where the church is situated, where the market is, where a particular item is. So the landmarks, you get to know them. The landmarks can be unique points, as I've indicated, where a particular junction is, or a pattern. So you realize that where the trees are, based on the patterns you have identified, you can use that to know where you are standing, the bearings, and then how to navigate to a particular place. And then the various features that you see. So you can see that there are several buildings lined up, indicating that there's a pattern or it represents something. So that can help you with navigation in a GIS perspective. Now we have the route knowledge. So from where you are staying to an identifiable landmark, you realize that you follow a particular route for a quite number of time. So as you are following that route will be the same place that you pass. Fly on that route for a couple of times, and then you get accustomed to that route. So that will be the route knowledge. You know that from here you go through this way, you pass here. Even if you close your eyes, you can narrate where you pass. In that regard, that is the route knowledge. But then you realize that as time goes on, you start to learn about the place. You start to realize that though you have seen the route, you've been planning on the route, but then there are other means of getting to the same place. So depending on interaction that you get with people staying around there, depending on how you've learned about your area of interest, you realize that you know other routes, shorter ones by which you can get there. So this knowledge helps you identify other means to navigate to the location that you want to go, and then how you can even cut down the distance or the time covered to reach the particular place that you want to navigate to. So basically, these are the 5 basic concepts we have in GIS: the location, the direction, the distance, the space, and then the navigation. Thank you very much for listening and joining this episode. Other episode will soon be released for you to get to understand more the basic aspects or the basic knowledge in GIS. You can send us email, you can send us Twitter, follow us on Twitter, Instagram, you can send us WhatsApp messages. Your concerns, your comments, your questions are all welcome. Let's get to the next episode. Thank you.